Hello, in this video we are going to see about aldol condensation. First let's see what is condensation reaction. So condensation is nothing but the addition of two simple compounds forming a complex compound with the elimination of a simpler molecules like water, carbon dioxide, like that. Okay. Two simpler compounds combined together forms a complex compound with the elimination of simple molecules. So that is a condensation reaction. Then what is aldol condensation? So it is an addition of two carbonyl compounds, and out of the two carbonyl compounds, one will be in the form of an electrophile. That is, one will be in a one will act as electrophile, and one carbonyl compound will act as a nucleophile, and they combine together and form a beta hydroxy aldehyde or a ketone, and this happens in the presence of a base. So that is a aldol condensation. So that is a addition of a enolate ion with carbonyl compound in basic medium to form a beta hydroxy ketone or beta hydroxy aldehyde. That is an aldol condensation. If we take two different carbonyl compound, we'll call that as a cross aldol condensation. If two carbonyl compounds are same, then it is a simple aldol condensation. For example, if you are taking uh, acetaldehyde, so both the acetaldehyde is reacting, or they are reacting and forming an aldol, then that is a simple aldol condensation. If you are taking acetone and acetaldehyde and the reaction proceeds, then that reaction will call as a crossed aldol condensation. And next is, what are the conditions necessary for an aldol condensation? The first main condition is it should have a alpha hydrogen. To undergo aldol condensation, the carbonyl compound should have a alpha hydrogen. So the formaldehyde, it doesn't have alpha hydrogen, so it won't take place, it won't undergo aldol condensation. Okay, and this condensation reaction takes place in a basic medium. Next, what is the importance of this aldol condensation? What is the use of it? So it is used to form a new carbon-carbon bond. So by this reaction, we can increase the carbon chain, length of the carbon chain, and so it is very useful in many organic synthesis reaction. Now let's discuss the mechanism of an aldol condensation. The first step is abstraction of proton, that is abstraction of alpha hydrogen by the base. So look at here. So this is your alpha hydrogen. What is alpha hydrogen is? So this is your functional group aldehyde CHO. So next to the functional group carbon, we call as a alpha carbon. So next to the functional group carbon, we call as an alpha carbon. The hydrogen attached to the alpha carbon will call as a alpha hydrogen. Okay, so first step is this alpha hydrogen is abstracted by the base and resulting in a nucleophilic carbon here. Okay, so resulting in a enolate ion, that is a nucleophilic carbon. So this is the first step, and it is also a somewhat a reversible reaction. Then next step, this nucleophilic carbon which was formed in the first step will attack the electrophilic carbon of the another aldehyde. So that is another acetaldehyde here, and this nucleophilic carbon, it attacks this electrophilic carbon here. Okay, so why it is electrophilic? It is electron deficient because it is attached to a electronegative oxygen. It will withdraw electron towards itself. So this carbon is electron deficient. It is an electrophile, and we have a nucleophile carbon, and this attacks this electrophilic carbon here. and it forms a new carbon-carbon bond. So new carbon-carbon bond is formed here. So look at here. So new carbon-carbon bond is formed here. The next step 3. So in the step 2, we have formed a alkoxide ion. That alkoxide ion gets protonated from the base at OH. So from the base, this alkoxide ion gets protonated and it forms an beta hydroxyaldehyde. Okay, so we have a aldehyde group here, CHO and CH2, that is a alpha carbon, and next to the alpha carbon is a beta carbon. So in the beta carbon we have a OH group, alcohol. So this is your beta hydroxyaldehyde, which we'll call as a aldol. Okay. So in the next step, so here the aldol, it converts into an enolate ion. So that is that alpha carbon has CH2 here. This CH, the alpha hydrogen, will be again abstracted and it forms an enolate ion here. It results in an enolate ion. Okay. After the aldol was formed, it again undergoes this, and which again results in the dehydration. Okay, once the aldol was formed, it undergoes a dehydration. So in the dehydration process, what happens is, first of all, this alpha hydrogen is again abstracted and forms an enolate ion, and in the next step, this enolate ion, in that enolate ion we have an OH group now that loses its hydrogen, it loses its OH group and it forms a unsaturated aldehyde. So it is this enolate ion loses its this enolate ion loses its hydroxide ion. This hydroxide ion, so why it is losing it, this electron will be shifted here and this OH leaves as OH minus, taking the bond pair of electron and results in the double bond here. So which results in an unsaturated aldehyde. And this is the overall reaction of aldol condensation. So we are taking a aldehyde which has a alpha hydrogen, which forms an enolate, and this enolate reacts with another aldehyde and forms a carbon-carbon bond, and which results in a beta hydroxyaldehyde. So this is a functional group aldehyde. This is alpha carbon and this is beta carbon, and beta carbon you have a OH group. So beta hydroxyaldehyde, which further undergoes dehydration and results in unsaturated aldehyde. So these are some of the examples of your aldol condensation. So whenever you can see two aldehydes, so two carbonyl group and in presence of a base, and the carbonyl group which has an alpha hydrogen, you can come to the conclusion it will undergo aldol condensation. So look at here. Here we have a ketoenolate nucleophile and we have a aldehyde. So here we have a alpha hydrogen. So this is a alpha hydrogen. Okay. So we have a alpha hydrogen. So it undergoes a aldol condensation and forms a bond here. Look at here. New carbon-carbon bond is formed. Okay. So this will be the intermediate. And aldol condensation with the loss of hydrogen, loss of water molecule, will get this compound, unsaturated ketone. Here is some of the examples of your aldol condensation. Thank you, and I will meet you in the next video.